All right, so this section is 6.3. It's trig functions of any angle. Again, we're going to review a little bit of what we did on Thursday in 6.1. 6.2 is right triangle trig SOHCAHTOA stuff, which we already did in the other chapter. That's why we skip it here. Your quiz, which is a week from yesterday, so on next Monday will be the first quiz of the fourth quarter. We'll cover 6.1 and 6.3. Okay, so in 6.1, which is what we did on Thursday, the most important things, because we're going to build on some of it, is being able to convert from degrees to radians. So we take theta, we multiply it times pi over 180. Then radians to degrees. And for those, we do theta times 180 over pi. We said just because it has or it doesn't have pi doesn't mean it's in degrees. Degrees has to have a degree symbol, and then if it doesn't, then it's in radians. We found coterminal angles that were in radians by adding and subtracting 2 pi, because that's a full circle, just like 360 degrees would be. We did arc length, which is that SOHR formula, theta times the radius, where theta is in radians. And then we did area of a sector, just like area of the piece of pie. And that's 1/2 theta times radius squared, again, where theta is in radians. Yeah.
Are we gonna have like the formulas given?
No. You're gonna, I mean, hopefully if you practice and you do the homeworks and that kind of stuff, you're gonna do this so often that you shouldn't really need them. But especially like radians to degrees and degrees to radians, like that kind of stuff. And then obviously I would just say arc length and area of a sector, you make sure that you're reviewing before your quiz, but.
And then like on the homework yesterday, we had like one where it was like S over R equals radians. Did we learn that?
S over theta. Well, that's just taking, so like if you got given this equation, but you got given, you can get any two of those three pieces of information, you should be able to solve the equation for the other one. Yeah. Anybody still copying that stuff down? So if it's something on, if there's something on there that you don't know very well, I would recommend rewriting this every day this week and adding to it when we get to the unit circle stuff. All right, this is what is called the unit circle. And we've built a little bit of this, like we've done the quadrant stuff, but we're gonna learn how to fill this entire thing out. You are gonna get given a blank one of these and you're gonna fill it out as part of your quiz grade, okay? So that part is memorization. Then how we use it, obviously, is what we're gonna do with it next. So this unit circle means a circle that has a radius of 1, which you see if you move in all directions, up, left, down, and to the right. The coordinate points there are 1 unit from 0. So to the right it's 1, 0, at the top it's 0, 1, to the left it's -1, 0, and on the bottom it's 0, -1. That's where these measurements come from, okay? And then if you look at the angles that are drawn to each of these, there are 3 angles, and they are your special angles based on special right triangles. 30 degrees, 45 degrees, and 60 degrees. So if you were to close in these triangles and use your ratios of 30, 60, 90, and 45, 45, 90, where opposite is 1, it would be 1, root 3 and 2 for 30, 60, 90, and then it'd be root 2 and 1 for 45, 45, 90. And then you do opposite over hypotenuse and adjacent over hypotenuse. That's where all these coordinate points come from. The difference is we are not going to do it that way. We are going to literally be able to fill in this circle and then use it with this information that the sine is your y, the cosine is your x, the tangent is your y over your x. And then I can flip all of those to get the reciprocal functions. So cosecant is 1 over y, or the reciprocal of sine. Secant is 1 over x, or the reciprocal of cosine. And cosecant is x over y, or the reciprocal of tangent. There is a pattern to filling out this unit circle, and I will teach it to you, okay? If you practice it, like if you do it with me today, you practice it again maybe 2 more times this week, you will understand the pattern, and if you do that, I promise you this is easy. The first time I teach this, every single time people whine like little babies, and then by the end of the week, it's not so hard, and you understand how to use it, and it makes it a lot easier, okay? But I will tell you right now that you want to make sure you're paying attention as we fill this in together the first time, because there are patterns to filling it in. All right, so flip to your blank unit circle. This is exactly what your, like the part on the quiz will look like. It's literally going to be this blank, okay? And we're going to build it together. So if you are doing anything other than looking at this blank unit circle, you better change right now. All right, so we're going to go through, there's multiple parts to this. The inner ring that has the little degree symbol is all the degree measurements. Then the little dash in the middle next to it is the radian measurement. And then on the outside is the coordinate points. And then in each corner, you've got your positive, negative. We're going to fill every single blank on this thing out. We're going to start with the degrees. So think about what we know about the degrees on this circle. Our first point, or where we start each time, is at 0 degrees. At the top is what? 90 degrees. On the left?
180.
Good. On the bottom? 270. And then double back around, and under that line is where we're going to stop. It's at 360. Now the pattern in between, the pattern for each one is 30, 15, 15, 30. It literally repeats that pattern every single section around. So to the first one in my first quadrant, this is 30. I add 30 and I get 30 degrees. Then I add 15 and I get 45 degrees. Then I add 15 and I get 60 degrees. And then I add 30 and it should bring me to the 90 that's already there. So 30, 15, 15, 30. I'm going to keep going. I go to the second quadrant. I add 30. I get 120. I add 15. I get 135. I add 15. I get 150. I add 30. I'm at 180. Do it again. Next quadrant, 30, 210, 15, 225, 15, 240, 30 brings me to the 270. And last time, 30 hits 300, 15, 315, 15, 330, and 30, 360. God bless you. 1/3 the way done. Questions so far? Okay, now we're going to fill in the radians. So the next little blank next to it is for radians, okay? We know the overall ones, well, hopefully we remember from Friday, where this would be 0 radians. At the top would be 1/2 pi, or pi over 2. On the left is 1/2 of my full circle, so it's pi. On the bottom is 1 1/2 pi, or 3 pi over 2. And then underneath, back around all the way, the full circle would be 2 pi, because that would be the circumference if my radius is 1.
Wait, what's the bottom one?
3 pi over 2, or 1 1/2 pi. It's 3/4 of the full circle, because 2 pi is the full circle, right? So halfway would be pi, and then halfway between that and 2 pi would be 1 1/2 pi. So you go by half pies if you go all the way around.
Oh.
Yeah? Okay. All right. So then in between, like all of these little things, there's a pattern. And you could sit here and you could convert every single one of those degrees to radians by multiplying by pi over 180, but you'd never finish. Okay? So understanding this pattern makes life easier. The angle that is closest to your x-axis, so the one we added 32 first, the one that is closest to your x-axis starts with pi over 6. So this is pi over 6 on the right. On the left, pi over 6. We're going to come back and change some of these, but we start with this. On the left on the bottom, pi over 6, and on the left on the right, on the right on the bottom, pi over 6. So the first ones are all pi over 6. Yep. Like the closest to the x-axis. The angles closest to the x-axis. So these 4, which are the first angles after and before the x-axis, those are your over 6s. The middle ones are over 4s. So pi over 4, pi over 4, pi over 4, pi over 4. And the ones closest to your x or your y-axis are over 3. Pi over 3, pi over 3, pi over 3, pi over 3. So those are your 30, 45, and 60 degree angles. Those are your reference angles in radians. Yep. Yep. So are we good so far?
Yeah.
Okay. In the first quadrant, we leave it alone. Pi over 6 is 30 degrees, pi over 4 is 45 degrees, and pi over 3 is 60 degrees. We leave them alone. In the second quadrant, the numerator is 1 less than the denominator. So it'd be 2 pi over 3, 3 pi over 4, and 5 pi over 6. 1 less than your denominator, which should make sense because we need it to be less than 1. Because 180 is 1 pi. Third quadrant is 1 more than your denominator. So 7 pi over 6, 5 pi over 4, 4 pi over 3. 1 more. And that would fall bigger than 1, but less than 1.5. Like each of those would be 7/6 would be 1 1/6. 5/4, 1 1/4. 4/3, 1 1/3. All in between 1 and 1.5. And then in the fourth quadrant, there's 2 ways to do it. One is it's 1 less than double the denominator because this is just smaller than 2. So 1 less than double would mean 5 pi over 3, 7 pi over 4, and 11 pi over 6. Or you can simply memorize 5, 7, 11. It is 1 less than double the denominator, or 5, 7, 11. Questions so far? Yep.
On the quiz, like you're just gonna give us the
It's literally going to be blank. Yeah. 2/3 the way done. Here's the easy part. Oh, sorry. Go ahead, Joe.
I was gonna ask you how much of the test is gonna
I forget how many points we gave. I'll tell you tomorrow. Okay. Here's the easy part. Okay. We already know the quadrant coordinates because we move to the right 1, which means this is 1, 0. Up 1, so this is 0, 1. Left 1, -1, 0. And down 1, 0, -1. Still with me? Okay. Every over 6, so we're just going to go in and fill in everything that has an over 6. The coordinate point is √3 over 2 and 1/2, and I'll explain where that comes from in a minute. Every over 6 is √3 over 2 and 1/2. So √3 over 2, 1/2. √3 over 2, 1/2. √3 over 2, 1/2. √3 over 2, 1/2. We're going to go back and fill in the positive negative signs. But the coordinate points are that. Every over 6. Every over 3 is the reverse of that. 1/2 √3 over 2. 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 And every over 4 is root 2 over 2 and root 2 over 2. Root 2 over 2, 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 root 2 over 2. Now, what's true about every coordinate in the first quadrant? Sign.
They're all positive.
They're all positive. So first quadrant, I'm going to leave alone. They would both be positive. In the second quadrant, what's true? X is negative. So this is negative, negative, negative. The Y is positive. In the third quadrant, both are negative. Because it's left and down, right? And then in the fourth quadrant, the Y is negative. Almost done. Yep.
Only for the like root 3 over 2 like those.
No, it's for any coordinate in that.
But like I'm saying like the 5 pi over 3 would it also be
No, the coordinate point, right? The angle, yeah. Okay, and then remember, all students take calculus. In my first quadrant, everything is positive. So all sine, cosine, tangent, secant, cosecant, and cotangent are all positive. In my second quadrant, the sine and its reciprocal function, which is cosecant, are positive. Negative would be cosine, secant, tangent, cotangent. You could literally put all others if you wanted to, as long as you establish which one's positive.
Do you have to write that?
Yep, it's going to be part of what you fill in. In the third quadrant, T for tangent. Tan is positive and its reciprocal function cotangent. And the negative is sine, cosecant, cosine, and secant. And in the fourth quadrant, C for cosine, cosine and secant are positive. Sine, cosecant, tan, and cotangent are all negative. Questions?
How do you get square tree over 2?
Say again?
Oh.
Where does that come from? So these are all from your right triangles. Like if I had a 30, 60, 90 triangle, this would be 1, this would be root 3, this would be 2, right? So if I wanted to find, let's say I want to find, the x is my cosine. So if I'm looking at the pi over 6 is 30 degrees. And if I wanted to find the cosine at pi over 6, which is the x, it would be adjacent, which is root 3, over hypotenuse, which is 2, which matches what my coordinate point is, root 3 over 2. If I wanted to find the sine is the y, it would be opposite over hypotenuse, which would be 1 over 2. So that's where they come from, okay? And you could survive, like you could do every single question from the unit circle with right triangles. They just take longer. Eventually, your goal would be to see an angle, figure out its denominator, and its denominator is going to tell you what the reference angle is, okay? Then from there, get the coordinate point. You'll know your sine and your cosine, and then figure out its location based on its quadrant, and that's how you'll know if it's positive or negative. So if I had this filled out, and this was literally in front of me, and I asked you to tell me what the sine of 4 pi over 3 is, I would go to 4 pi over 3, the sine is the y, and my answer would be negative root 3 over 2. It's that fast. If I asked the cosine at 7 pi over 4, I'd go to 7 pi over 4. The cosine is the x, And my answer would be root 2 over 2.
So this will also be a reference sheet on the test?
No. I mean, you'll fill it out and then you'll get to use it to answer the other questions for your quiz. I'm not sure what we're going to do with about the test yet, but some years we give
On the quiz, on that.
on the quiz, yes. So like you'll get it, it's part of your quiz, and then you'll answer questions based on it, okay?
So if this is wrong, like the whole quiz would be wrong?
Yeah, but that's not going to happen. I've taught this a lot of years, and no one gets it all wrong. Sometimes people miss up signs, but it just doesn't happen. You're not going to do it. You're not going to be the first to screw this up, okay? I've taught this a lot of years, and to all levels of kids. If you practice this, I promise you, you'll be okay. Okay, so now we're going to figure out how to use it. Again, the importance of knowing how to fill it out is there, but now we're going to figure out how to use it. So if you want to, like if you want to screenshot yours and you can use it as we go through the rest of the lesson, feel free. If you want to screenshot the one that's in the notes. So these are the types of questions you're going to see, okay? Notice that most of these are they are actually on my unit circle. There are some that are negative. When we get there, we'll go over what to do there, okay? And some of them are sine and cosine, but then some of them are also tangent. So if you really have two choices when it comes to tangent. One is do y over x every single time. The other thing is I'll teach you to memorize tangent because it's the same thing every time. For tangent, if it's over 6, then it's root 3 over 3. That's what you would get if you did y over x. If it's over 4, then it's 1. That's what you would get if you did y over x. And if it's over 3, it's root 3. I remember it because it takes 2 3s to make 6, and it only takes 1 to get the 3. If you wanted to memorize that, that's going to save you some work, okay? Obviously, your sign changes as you move around the unit circle, but the value of tangent will be one of those. Or if it's a quadrant angle, it's going to be 1 or -1 or, no, it will be 0, 0 or undefined as you move around your quadrants. So at sine of 3 pi over 2, right, we're going to locate 3 pi over 2 on our unit circle, which is here. The coordinate point there is 0, -1, and sine is the y, which means it's this -1. What's the cosine at 3 pi over 2? 0. What's the tangent at 3 pi over 2? Undefined, because it would be y over x, and that's undefined. If 0's in the bottom, it's undefined.
Wait, how is it?
Because it'd be -1 over 0, and anything divided by 0 is undefined.
Oh, it's tan.
It's tan, yep. All right, cosine 7 pi over 4. Find 7 pi over 4 in your unit circle. What quadrant is it in? It's root 2 over 2 and negative root 2 over 2. It's in the 4th quadrant. What's the cosine there? Root 2 over 2. It's the x. What's the sine there? Negative root 2 over 2 because it's the y. I'm going to go back to 6 in a minute. I'm going to keep going here. Go to cosine at 2 pi over 3. So I go to 2 pi over 3. And the cosine there would be -1/2. And cosine at 4 pi over 3. Now I'm in the third quadrant. 4 pi over 3. Cosine there is -1/2. Questions on those? Sorry? I said I was going to go back to it. Yeah. Questions on those so far? So -5 pi over 3 is obviously not on our unit circle. There are two ways to do these negatives. One is go in the reverse order. So if it's -5 pi over 3, I'd be going this direction 1 2/3 pi. Because 5 pi over 3 would be would be 1 2/3 pi. So if it's negative, we go the other direction. This would be 1 pi, 2/3 pi would be the over 3 in that last quadrant, if I go in this direction, which is the pi over 3 angle. And the tan there would be what? positive root 3. That's one way to do it. Go in the other direction. The other way, and honestly, I think almost the easier way, is make it positive. So I would locate positive 5 pi over 3, which is in my fourth quadrant, fold along your x-axis. So like a hamburger, top to bottom, and wherever it overlaps, which would put it up here, is the negative version of that same angle. So if it was positive 5 pi over 3, if it was negative 5 pi over 3, I would make it positive 5 pi over 3 and then fold along the x-axis, and that's where I would know it would go. So if I said negative 2 pi over 3, I would locate 2 pi over 3, which is in the second quadrant. I would fold like a hamburger, and it would reflect down, and that's where the negative version of that angle is.
Is it just always the same thing but negative?
Yep.
Can you just find the coterminal?
You can. You can also add 2 pi and find the coterminal. Sure. Yeah.
Once you fold it and you find the new angle, then what do you do from
Then you would use that coordinate point. So this over 3 is negative 1/2 and negative root 3 over 2. So if I was looking for cosine, it'd be negative 1/2. If I was looking for sine, it'd be negative root 3 over 2. If you're looking for tangent, it's positive root 3.
Oh, because
You follow the sine rules of the all students take calculus. But then if it's an over 3, tan is root 3. If it's an over 3, tangent is root 3. That's what we wrote up here. So your goal would be to know, especially the over 3s, the over 4s, and the over 6s so well that it is quick recall. Like because you're obviously going to get ones that are not just unit circle. If I had 11 pi over 3, I immediately say this is an over 3, and at an over 3 my coordinate point is 1/2 and root 3 over 2, and my tangent is root 3. I know all of that already. This is my cosine, this is my sine, this is my tangent, just from knowing it's an over 3. Then the 11 pi over 3, I'd have to figure out what quadrant that's in. 2 ways. 1, find a coterminal. Subtract 2 pi until it's something on your unit circle. The other, and how I would tell you to do it, is convert this into a mixed number. So 11 over 3 is what? In mixed number format. It's 3 2/3. So here's the trick. The whole number tells you to start on the right if it's even, and on the left if it's odd. So if I'm at 3, I literally would have gone 1, 2, 3, or I jump right to 3 because it's odd. And then this is my halfway mark. Is 2/3 less than a half, or is it more than a half? It's more than a half, which means this is in the fourth quadrant. In the fourth quadrant, cosine is positive, so sine would be negative and tan would be negative. So the goal would be able to do that with any number.
So it doesn't matter what's on the top, it just really matters it's over.
For the coordinate point. Then what's on the top tells you which quadrant it's in. Yep. So 17 pi over 6 is an over 6, right? What's the coordinate point at over 6 is? Root 3 over 2 and 1/2. And tan would be root 3 over 3. 2 3s make the 6. So this is my cosine. This is my sine. That's my tangent. Now 17 over 6 becomes what in mixed number form? 2 and 5 6. So the 2 tells me I'm going all the way around my circle once. And then is 5 6 bigger than a half or less than a half? Bigger than a half. So I'm at the over 6 in the second quadrant, where sine is positive, cosine is negative, and tangent is negative. Eventually, you want to get there. Obviously, there's going to take some practice to get there, but that is eventually what you want to be able to do. I could throw any number at you, and as long as it's an over 6, an over 3, an over 4, or an over 2, because that's your quadrant ones, you should be able to find it like that. The quiz questions are not going to come directly from your unit circle. They're going to be coterminals. Questions? So what if I just said 25 pi? Where is that? It's an odd whole number. Where's the odd whole numbers?
1 pi, like negative, because it's spun around like 12 times.
Yep. So it's on the left. If it was 26 pi, it'd be at the right. So my cosine, my sine, my tan would be 0 over negative 1, which is 0. I could do that with every over 2 as well. Any over 2, like either you're going to go to the top or you're going to go to the bottom. And then from there you'll get your coordinate points. Because 1 pi is on the left. So if I did 25, it would be 1, 2, 3, 4, 5, 6, all the way around until I got to 25. And if it's odd, it's always going to finish on the left. And if it's even, it's always going to finish on the right where 2 pi is.
And then how do you know yes or no if the second one? Because it's positive. Okay.
What do you mean the second one?
Why, if it's on the left, why would it be in the third one?
It's on the axis if it's a whole number. So it's not in a quadrant. It's on the axis.
Oh.
If it's a whole number, it's literally on the axis at 180.
Okay.
So that's why it's negative 1, 0.
If it's over 2.
Then it'd be at the top or the bottom. So like 25 pi over 2. I do the same thing. I convert that into a mixed number. This is 12 and 1/2 pi, right? So 12 says go to the right because it's even. And 1/2 beyond that is at the top. Yep.
So I had a question. So the 17 pi over 6.
Yeah.
You get 2 5 over 6.
Yeah.
Would you be able to just use the 5 pi over 6?
Yeah, because it's 2. Yeah. Or 4 or 6 or 8.
So could
You could find a coterminal.
I'm saying, like, do you necessarily need like the whole number?
No, not well. I mean, you need it, but you can use its coterminal. You could keep subtracting 2. It's just if that number is like 22 and 5 6 pi, you don't want to have to keep subtracting 2. You want to know 22 would be at the right, so I'd go past it 5 6. If it was 22 and 5 6 pi, I don't want to have to keep subtracting. Right. So you're doing what we're doing without the visual. The even whole number would put you on the right. And then you just have to go to 5 6. Does that make sense?
Yeah.
Okay. If it was an odd whole number, now you're starting here. And then you'd be going 5 6, which is in the 4th quadrant. Yeah.
So the whole number determines like.
Start at the right or start at the left. Yep. Even on the right, odd on the left. And then from there, then the next question is smaller than 1/2 or bigger than 1/2. So I'm going to stop. We're going to save the rest of the notes. When you look at the WebAssign, you'll see that there are questions that are just like these, where you're finding one trig function, and then there's somewhere it'll say like, using the angle, find sine, cosine, tangent, and you're finding the 3 parts. Okay? All of these are kept exact. We haven't touched our calculators at all. We will eventually get to these things where you're using your calculators, but in radians. And then the very end of this is finding the angle given the trig function. So we go back to that, but all of that involves the calculator. The very last one is the reverse, with using the unit circle point. So the rest of it saved. We're going to do that tomorrow, okay? But I would say you want to practice unit circle and you want to practice the questions that ask you for the trig functions of non-calculator questions.